We're going to go through this worksheet in class today, and I'm just doing an answer key, summary answer key. So for anybody that's been absent or just needs to hear it one more time, you can play this at your own pace. So for each of these problems, we're trying to find the slope of the line and the y-intercept, and then we're going to write an equation. So a three-part thing. So remember from the other last couple of class periods, we did slope, and we found slope in different ways, but the variable or the letter we use to denote slope is m, and when we're drawing graphs, it's really helpful to think of slope as the rise over the run. Another way to think of it is also the change in y over the change in x. So first things first, we're going to focus on slope on these graphs, and we'll just move those up there as a reference. And if you forget, you can refer to those notes. So I know the quality of this is a little hard to see, but the idea when you're finding slope is to find two exact points. So I'm going to identify what I see as an exact set of points here. I see that this hits right at 3 on the y-axis, and it also hits at the point 27. So I like to use the triangle as a visual. My rise and my run, they're up and to the right, so they're both positive. I went up 4 and to the right 2. So my change in y over change in x, or my rise over run, is just up 4 over 2. And I can simplify that to be 2 over 1. So we just say that's a slope of 2. And then for the intercept, we look at the graph, and right here, the y-axis is crossed by the line at point 3, so the intercept is 3. And then another thing to add up to our notes is the equation of a line is in the form y equals mx plus b. So now we can say y equals m, which is 2, times x plus 3. So if we look at this, call that problem 1, and we'll look at this as problem 2. We're going to repeat the process, but when we do change in y over change in x, we notice that in reading left to right, this is like a downhill slide, versus reading left to right here, you're going uphill. And when you go uphill, you have a positive slope. And when you go downhill, you have a negative slope. So just keeping that in mind, it's always good to think about that before you actually do the work. So I find two exact points, and there's lots of combinations. So one point I see right there, I'm going down 4, and then I'm going over all the way that distance, which is 8 units. So my rise over run, because I'm going down 4 and over 8, I think of that as a negative 1/2 slope. I think if you look close, you could also have seen and might be wondering why it didn't go from here to here. And I'm just trying to demonstrate that there's more than one correct way to get the slope. So here we're going down 1 and over 2. So since we went down and to the right, we have a negative slope. So our slope is negative 1/2. and cleaning this up a little bit so you can see the y-intercept. The y-intercept is 2. So the equation of this line is y equals negative 1/2 x plus 2. We could work with intercept first. I can identify right off the bat the intercept here is 3, and then use this key point. So up 1 over 3. So here my slope is rise over run, which means the same thing as changing y over changing up x. I went up 1 over 3, so I'm just going to leave my slope as 1/3. And so my equation is y equals 1/3 x plus the y-intercept of 3. Here the y-intercept is negative 7. Looking for 2 key points, I see these 2. It's downhill, so I notice I have to drop down 6 units, and I go to the right 2 units. So my slope is, sorry about that, drop of 6, run of 2. Again, if I divide by 2 to get this simplified, I get negative 3 over 1. So the slope is negative 3. Therefore, my line equation is y equals negative 3x minus 7. You might like to think of it as y equals negative 3x plus negative 7. They're the same. On these tables here, to find the y-intercept, if we just look, for example, at the picture above, this y-intercept is the coordinate 0, 3. And this y-intercept is the coordinate 0, negative 7. So the y-intercept is found when x is 0. So the y-intercept here would be 5. In other words, if you were going to draw a little sketch of this graph, it would start up at 1, 2, 3, 4, 0, 5. And then the next point would be like 1, right about there, and that would be 1, 9. And you would have a line that would go through those points. And it would look roughly like that. So just to keep in mind, the intercept shows up in a table when x is 0. The slope is how much the change in y is divided by how much the change in x is. So the slope is change in y over change in x. And in this problem, we see the slope is up 4 because it's increasing. It's going up. And over 1. So the slope is 4. So my equation is y equals 4x plus 5. The thing to keep in mind is, even though I drew a sketch, when you have a table, you shouldn't need to draw a sketch. Although it's not a bad idea every once in a while to draw a sketch with a table to make sure you understand what all your values look like. So here, I noticed that I could get the slope because I'm dropping 4. So here I'm dropping 4. And here I'm increasing 2. So my slope, change in y, over change in x is a drop of 4 to a change of 2. When I divide by 2, I get negative 2 over 1, so my slope is negative 2. It's a little harder to find the intercept because I don't have when x is 0. But I can follow the pattern backwards. I'm dropping down from 8 to 6, 6 to 4, 4 to 2, so I could drop down to when x equals 0. I could continue the pattern. So if you look on the right-hand side, I'm going up by 4. 0 plus 4 is 4. Add another 4, I get 8. Add another 4, I get 12. So you can sort of add to the table this coordinate 0, 12. So B is 12. That would be sort of a level 3 problem at this point. So y equals negative 2x plus 12. That's all I'm going to do on this video. If there's time, I'll make a video of the other side.